A few years ago I bought this chip, the MC34063A, to do experiments with. It's a buck converter. It can convert voltages down and also voltages up. It's a chip from Texas Instruments, and you can go to the World Wide Web, surely find it on the website of Texas Instruments. And I have tried to make an experimental circuit with it, and it is the step down converter. So this is that schematic on the Texas Instruments website. Input 25 volts, output here they tell 5 volts, but I've made it in a somewhat other way, and perhaps that has the effect that I now read on my meter 6 volt out instead of 5 volt out. Anyway, there's also here a filter, and I will tell more about that when we are looking at the oscilloscope views. It's 1 microhenry and a small capacitor, and the reason is that here on the output we have a kind of peak voltages. Of course this is a kind of oscillator chip, and when you study the datasheet on the Texas Instruments website, you can see many schematics, step down and step up converters. Perhaps it's interesting to pen over a little bit. All the properties of that chip are showed, and this is a step up converter application. And of course I have to pen over a little bit, but when you have a computer or a smartphone, you can surely find out the exact circuit that you can make, both for stepping up a voltage and stepping down a voltage. And I also found today that there is a new type number with other properties, perhaps with other properties, of course I did not test it, but anyway. A step up converter, and now we go to the step down converter that I've made. And I will show how I made it. There is a small inductor here, 220 microhenry. It does not have to have a high quality factor. And there is here also a Schottky diode. I did not use that Schottky diode, I used a normal diode, and perhaps that's the reason why I find here on the output 6 volt instead of 5 volts. Anyway, I don't know that exactly. You can do your own experiments. Say for instance, order the Schottky diode, and anyway, this is that filter that filters out peaks. So this is what I've made today. Let's look to the circuit. Here is it on the breadboard, on my workbench, and you can of course see that I made it in the classical way that I always make my circuit with brass nails. That has advantages, but when there is an oscillator, that in certain cases that cannot sometimes not work very precise, but I was very glad that with this tiny chip here you see it compared to a resistor, it's so tiny and it's a kind of pain to solder it in, and there are certain tricks, but perhaps that will make this video too long. What I've done is make the first connection here, connect it to that brass nail so that it is fixed, etc, etc, and then the other one here, and then slowly solder all the connections from the downside to the upside, or in a reverse way. Anyway, this is how it was made on a piece of properly lacquered wood. I was talking about not the instability, but the reason why they in this data sheet of Texas Instruments tell you that you could need, not always necessary by the way, that you could need a filter. And here you see on my scope, say the peaks here that are present on the DC output on, in my case, 6 volts. And I'm sure when you make it in the exact way like Texas Instruments showed it, you will surely see exactly the same peaks, because it is an oscillator. So this beautiful tiny chip here is an oscillator with a frequency dependent capacitor. That capacitor is here, and it, in my opinion, it works in combination with this coil here, the microhenry coil. Anyway, so here is what I have made. And in the data sheet you can see and find that this circuit can bring out approximately, no, not approximately, but 1.5 ampere peak. Well, is that real? I really don't know. You do your own experiments. And this chip is very cheap, so you can damage it by taking out a too high current. I was very, say, doing my experiment here when taking the load output resistor. I was very much on the safe side. So with a 1K resistor at its output, the current out is 6.2 milliampere, and with a 200 ohm resistor, that's now realized here, with this bunch of resistors, it is approximately 30 milliampere. Does it get warm or hot? No, not at all. So here we have 30 milliampere out, and the chip does not get hot. So that gives a little bit hot, a little bit warm anyway, with this output current, 30 milliampere. So again, the circuit, I think, is a very usable chip. You can do your own experiment trying to get as much current out. Input voltage is now here 25 volts, output voltage is 6 volts. And you can see that on this analog meter, 6 volts. And even when I did all these experiments with trying to get a good output current, a higher output current, it stayed exactly on 6 volts. So that's, in my opinion, a very good property of this chip. And I am, say, in a certain way, trying to believe that in the best situation, this chip can really give out 1.5 volt ampere as a peak. In reality, say 1 ampere or so. Anyway, so I think it's a very useful chip, and there is a new type of this chip. You can find it on the World Wide Web. And of course, this is, say, a surface mounted device chip. It's now soldered in here. with, say, very coarse pieces of wire. Took some pain to solder it in, but anyway it worked. And here is my voltage supply. Its maximum voltage is 26 volts. So now there is approximately 25 volt in here and 6 volt out. Here 6 volt out, 30 milliampere, and here 25 volts in. I did not use that Schottky diode like I thought. I've used a normal diode. In the original schematic of Texas Instruments they talk about a 1N5819. It's a Schottky diode. I've searched that on the World Wide Web. Schottky diode has, as far as I know, in general a somewhat smaller voltage drop, and I've used a normal silicon diode and it also works. That was more or less all to tell. Thanks for watching. I think it's a very usable chip. Converter chip. This is only step down conversion, but of course you can also use it for step up conversion, and much more info is in the datasheet of Texas Instruments. Thanks for watching. And all kinds of instructions are given in the Texas Instruments datasheet about how to, say, solder this chip, avoid stray capacitors, etc. But the good property of this chip is that even in this sloppy haywire making, it works very nice.